Hello, this is Yukun Jiang, and I will talk about the M4 final hackathon. First, I read in the training dataset and the test dataset, and I checked the number of unique values in each feature, and I also checked the new values. And then I checked the class imbalance and found that in this variable stroke, by plotting its distribution and printing the normalized value count, showing that most cases belongs to class 0, which is no stroke, with very few in class 1 stroke. And through the descriptive statistics, I am able to check their statistic values. And through this plot, I plot histograms for numerical features like age with 20 bins to visualize their distributions and check outliers through box plot. I also plot a correlation matrix, which shows the variables correlations. And I visualize the relationship between numerical variables and stroke and found that people with certain characteristics were more likely to have a stroke. And I also encode categorical variables using one-hot encoding and convert the ever married column into a binary format. Then I created 3 new categorical features by binding continuous values. And I applied standardization to scale the numerical features. And I address the class imbalance in the dataset by applying SMOTI-TOMC instead of SMOTI, ensuring the minority class reaches 20% of the majority class. And I dropped the duplicates if found. And then I tried to implement the model. First, I trained a classification model using random forest. And I tried to compute feature importance, which shows that age is the most important feature. And I extract all features sorted by importance and plot them. I also calculated the F1 score for the random forest model, which is around 0.93. And I also ran a PyCaret to check which is the best model. And I found that maybe LDA model might be the best model. So I first trained it. And after cross-validation, which can reduce the overfitting, I found that the average F1 score is around 0.945. So it's a little bit higher than the random forest. And I also draw a learning curve here. It shows that the number of training as the number of training examples increases, the training F1 score decreases, while the validation F1 score improves slightly, indicating a reduction in overfitting and a better generalization. And I also plot the confusion matrix and the classification report, which shows that the LDA model performs well on the majority class, but struggles with the minority class, leading to a low recall and precision for class 1. I also try to remove the 5 most useless features, but F1 score is very similar with before. And I also try to find the optimal threshold for the best F1 score, and it turns out to be 0.34. Then I checked the other models like LightGBM model and conduct the similar steps as before. I try to cross-validation and print the average F1 score. And here I also use the hyperparameter tuning for light GBM model. And after tuning, actually it's very similar as before. And I also checked another model, which is XGB. I also conducted cross-validation and hyperparameter tuning, the same steps. And lastly, I checked another model, which is gradient boosting classifier. And after cross-validation, I print its F1 score. So finally, I try to rank the F1 score, and I find that LDA with less features has the highest F1 score, and the original LDA model has a very similar F1 score. So both of them are best models. And XGB Boost after tuning ranked third. So here I conduct a voting classifier which combines the original LDA model and the XGB tuned model. And after cross-validation, I found that the F1 score is the highest, which is around 0.9467. Actually, it did ranked first. So my final model is the voting classifier. And lastly, I applied the final model to the DF test set. And as I mentioned before, I set the best threshold as 0.34. So that's my final hackathon. Thank you.